both. In order to simplify a rational expression, you'll remember what we want to do is basically factor everything. We're going to employ all our different factoring techniques, GCF, difference of squares, sum or difference of cubes, sum product factoring, splitting the middle term, maybe guess and check. So make sure to review all your different factoring techniques. As I factor the numerator, again, this is sum product factoring, two numbers that multiply to equal 25 and add to equal 10. That would obviously be positive 5 and positive 5. Okay, we could write this as x plus 5 squared. I actually prefer to leave it as x plus 5 times x plus 5, but that's really up to you. The denominator, again, the sum product factoring will factor as x plus 5 times x plus 4. Now, notice the directions ask us not only to simplify, but also to state any restrictions on the variable. Okay, the reason being is that you'll remember a fraction is essentially a division problem, and you cannot divide by 0. So we have to make sure that the denominator does not equal to 0. So what I'm going to do is I'm going to take each factor from the denominator only and set them equal to 0 and solve. Okay, and so I'm looking for those values that would make the denominator 0. So you can see pretty clearly that x equaling negative 5 would make the denominator 0, and x equaling negative 4 would make the denominator 0. Those are my restrictions, and I'll put those back in at the end when I come up with my final answer. Now, what I can do is I can go ahead and simplify this expression now that I have it factored. If you remember, the rule says that we can only simplify factors, entire factors. We cannot simplify just pieces of factors. So essentially, the rule I like to say is if something's got an addition or subtraction sign next to it, you can't just cancel one part of that addition or subtraction problem. So here you notice that we can cancel out an entire x plus 5 with an entire x plus 5. What we're left with is x plus 5 over x plus 4. Some students might ask, hey, can we simplify? Can we cross out those x's? No, because they're part of a larger expression. So those are not eligible. Again, only factors can be canceled. So my final answer would be x plus 5 over x plus 4, with the understanding that x cannot equal negative 5 and x cannot equal negative 4. Okay? So now let's take a look and see how this relates to multiplication and division. Before we do that, I want to take a look back at multiplying just some numerical fractions. So no algebraic expressions involved here. Most likely when you learn this in whatever 5th or 6th grade, what you learn to do is you learn to look and simplify either vertically or diagonally. And so in this example here, we might cancel out and say, oh, okay, I can cancel the 4, it goes into itself once, and it goes into 8 2 times. And I might simplify and cancel out the 3 and say that it goes into itself once and it goes into 9 3 times. And so we'd end up multiply through and we'd end up with 2/3. And that's great. I want to show you sort of a little bit of an alternate technique that you probably didn't employ, but will help us with the rational expressions. And here's what I want to do. I want to take that same problem, but I want to factor it. Essentially, I want to rewrite, when I can, rewrite any of those expressions in terms of their factors. So 4 can be rewritten as 2 times 2. The 8 can be rewritten as 2 times 2 times 2. And then finally the 9 as 3 times 3. Notice the 3 is a prime number, so I just left it alone. Now what I can do is just like we did before, but I can see when I'm canceling, oh, okay, I can cancel this 2 with this 2. I can cancel this 2 with this 2. I can cancel the 3 from the left-hand numerator with one of the 3's in the denominator. And again, so everything is canceled out with the exception of the 2/3. So remember, when you're simplifying fractions, you can cancel or simplify vertically, like we did with the rational expression above. You can cancel diagonally, like we did on this problem. You cannot simplify or cancel horizontally. Remember that rule. So please don't cancel or simplify anything horizontally. So let's jump back into the rational expressions. So my first step, just like we did in the rational expression above, is going to be factor everything I can. Okay, sometimes this will take more than one step. When I look at the left-hand numerator, I notice I can pull out a 5, and I'm left with x squared minus 25. When I factor the left-hand denominator, I can pull out a 10x, and I'm left with x plus 5. The right-hand numerator, prime, so I can't factor that, but in the denominator I can pull out a 6, and I'm left with x minus 5. Okay, now that I've got it factored, I want to pause here for a second and identify the restrictions. Okay, so again, I'm going to take any factor from the denominator, and specifically those factors that contain an x, or a variable, I should say, and set them equal to 0. So I have 10x equals 0, I have x plus 5 equals 0, and I have x minus 5 equals 0. I don't need to worry about setting the 6 equal to 0, because 6 equals 0 is sort of a nonsense expression. It doesn't yield a restriction for x. Now when I solve these, I find that if x equals 0, the denominator would equal 0. If x equals negative 5, the denominator would equal 0, and same thing for positive 5. So now I've identified my restrictions. I can go ahead and simplify this problem, and again, remember the rule. Oops, actually, I can't simplify it just yet. I haven't completely factored, so let me factor that left-hand numerator. Okay, over. So again, we got to make sure that we factor completely. And we got the x minus 5. Okay, now I'm ready to go ahead and start to simplify. And again, I can simplify vertically, straight up and down, or diagonally. So I can cancel out the x plus 5s. Okay, the 5 goes into itself once, 5 goes into 10 twice. The x minus 5s can go. And then finally the 3 into itself once, and the 6 into itself twice. So just be careful. Sometimes we tend to lose values here, so just be careful, make sure you don't lose any values. I'm left with, in the numerators, everything is canceled except for the number 1. There's got to be something left in your numerator. In the denominator, it looks like canceled everything with the exception of the 2 times 2 and the x, so that's going to be 4x. So this final value simplifies to be 1 over 4x, with the understanding that x cannot equal 0 or positive or negative 5. Those are my restrictions. Okay, let's take a look at another example. Okay, so again, we said our strategy is going to be, step 1, factor everything we can. Okay, left-hand numerator, some of you might choose to split the middle term, only because the leading coefficient and the constant term are prime. I'm going to look to use guess and check when I factor those, so I know that my first term will have to be a 2x and an x. I know that I'm going to need multiplying to equal a positive and adding to equal a positive, so I know both of my second terms in the binomial will be positive, and I'm looking for 2 numbers that multiply to equal 3. So it's going to be a 1 and a 3. Those are my only options. So that really the only choice is where do I put the 1 and where do I put the 3? Well, I'm going to put the 1 there and the 3 there, and now I'll FOIL this out, and so I get the 2x squared when I do the first times first. Outside is 6x, inside is 1x, and so those add to equal 7x, so I know I have the right factorization. If I didn't, I could just switch the 3 and the 1. On the right-hand numerator, difference of squares, so x plus 4 times x minus 4, and the right-hand denominator, x plus 5 and x plus 3. Okay, now I've got everything factored. Don't forget my restrictions. I'll take each factor only from the denominator, set it equal to 0. Okay, and so I get x equals 4, x equals negative 5, and x equals negative 3. These are going to be my restrictions. I'll put them back in at the end. Now again, I can cancel vertically or diagonally. So x minus 4 with x minus 4, entire factors only. X plus 3, x plus 3. And that looks like just about it. So my final answer, this will equal, I'll just put it together. And keep in mind when you put this together, you can leave it in the factored form. No need to multiply the 2x plus 1 times the x plus 4. This is called a simplified factored form. This is actually more desirable. We'll see this once we get to the graphing, etc., that this is a preferred form. And our restrictions, don't forget to state your restrictions, x cannot equal 4, negative 5, or negative 3. Okay? So let's take a look now at a division problem. Okay, so again, going back to how we divided when we first learned about fractions. And you might remember the rule. I know there's one thing you remember, but you might remember the rule that when we divide with fractions, essentially what we're doing is we're multiplying by the reciprocal. So the idea here is that we can change 3/4 divided by 3/2 to make it 3/4. We don't touch the left-hand fraction, okay? But we are going to multiply that by the reciprocal value, by 2/3, okay? Now, of course, the way you guys remember it from middle school is keep, change, flip, right? You keep the first fraction the same, you will change the division sign into a multiplication sign, and you will flip the right-hand fractions, okay? So that's, if you remember, keep, change, flip. That's the idea that we're employing here. I like to say we're multiplying by the reciprocal, but I know you guys love your keep, change, flip. Okay, so let's try it with some rational expressions here, and there is one difference that we have to be careful with, and that's the restrictions. So our first step going to be the same as all the other problems that we've done. We're going to factor everything we can. So if I factor my left-hand numerator, it looks like we got a lot of GCFs to take out. So I have 3 times y minus 4. The left-hand denominator, I've got a 2 times y plus 2. Okay, I'm keeping this a division problem. I can pull out the 6, and I'm left with y minus 4. And the right-hand denominator, I can pull out the 4, and I'm left with y plus 2. So at this point, we're going to take any factors in the denominator that contain the variable, set them equal to 0. So y plus 2 equals 0, and y equals negative 2, we can see as a restriction. Okay, so now I'm ready to go ahead and flip my right-hand fraction, make this a multiplication problem. So I have 3 times y minus 4 over 2 times y plus 2. That is going to be multiplied by 4 times y plus 2 over 6 times y minus 4. Now, notice what's happened here is we've sort of introduced a new factor in our denominators, the y minus 4. So that, we have to consider that as a restriction as well. So we set y minus 4 equal to 0, and we see y equaling 4 would make the make the denominator equal to 0, which is a restricted value. Now I'm ready to go ahead and simplify. Again, we can cancel vertically, we can cancel diagonally. So the y plus 2's will go, the y minus 4's will go. The 2 and the 4, that will become a 2. The 3 and the 6, that will become a 2. The 2 and the 2, so it looks like we're just going to be left when all said and done is 2 over 2 or 1, okay? And that is with the understanding that y cannot equal negative 2 and y cannot equal 4, okay? So biggest difference between the division problem and the multiplication problems, we have to identify restrictions twice, essentially, anytime we have a factor in the denominator, and then obviously the keep, change, flip aspect of it. All right, let's take a look at example 4. So again, I'm going to go ahead and factor everything I can. So I have, looks like x minus 3 and x minus 2. Can't really factor the x to the third. And I'm leaving this as division. Looks like x plus 5 times x minus 2 over 4x squared. Now, set our restrictions. Both x to the third equaling 0 and 4x squared equaling 0 are going to yield a value of x equaling 0, okay, if we were to solve that. So we know that x cannot take on a value of 0. That's going to be restricted. So now I'm ready to go ahead and multiply by the reciprocal or keep, change, flip. So let's rewrite this as x minus 3 times x minus 2 over x to the third times 4x squared over x plus 5 times x minus 2. And again, notice what's happened here is we've introduced new factors to our denominator. So we have to consider those for restrictions as well. So x plus 5 equals 0, x equals negative 5, and x minus 2 equals 0, x equals 2. So those will become additional restrictions. All right, let's go ahead and cancel. So the x minus 2's can go. I've got an x squared in the right-hand numerator and an x to the third in the left-hand denominator, so I can cancel out the 2 x's here with the 2 of the x's there, and so I'm just left with x to the first in the denominator. If I put this all together, x minus 3 over x times x plus 5, okay, with the restrictions that x cannot take on a value of 0, negative 5, or 2. Okay. All right. I want to look at one more example. I might not take you all the way through, but just take a look at one more example here. The biggest difference here is that this is written vertically. Well, I'm going to be honest with you. The first thing I'm going to do for this problem is I'm going to change it so it's written horizontally. I feel more comfortable when it's written horizontally. So 8x squared y over x plus 1, and that is being divided by 6x squared y over x plus 1.